Is it working? So hello everyone. 2 weeks ago I presented a paper which was called BoxeR box attention for 2D and 3D transformers, and there were some questions about how key, query, and values were obtained. So now I will try to answer them and make a quick review on this paper. This paper was published in CVPR 2022. So the main idea of this paper is that the authors present a BoxeR, which is attention layer, short for box transformer, and this layer attends a set of boxes by predicting their transformation from a reference window, and using this style of prediction, they perform object detection and instance segmentation. This is the overall structure of how the box attention computation looks like. They apply the same formula of attention that all of us know is a softmax of QK transpose and multiplied by value matrix. Specifically for this paper, they have the following dimensions for each of the query, key, and value. For query, they have n by d. Key is m by m by d, and value is n by m by m by dh. N is the number of bounding boxes which are given as input to the encoder. So now let's discuss how do we generate boxes of interest, which are our main input to the encoder part. So we have object-centric box, which is this one. It's used as a reference window, and the motivation of using this instead of anchor boxes is that authors say that this object-centric box is more informative than the traditional anchor boxes which used in region proposal network. So during inference, the model predicts the geometric transformations using this window. They apply scaling and translation, and they obtain transformed windows like this. And these transformed windows, which are boxes of interest, are given as input to the encoder, and from this box of interest, we generate key, query, and values. This is a formula that authors suggest for scaling and translation methods of transformation regarding to the reference window. Now let's discuss how query, key, and values were obtained. The same as from the last presentation, query is obtained in the same way. It is a center point of the bounding box BI, meaning if we have this bounding box, the query will be the center of the bounding box. Value is obtained the same as before using bilinear interpolation. This is a proof from the paper itself, where the authors say that they use box of interest BI and they extract a grid feature map VI of size m by m using bilinear interpolation. While key I is obtained using a one-to-one convolution to the feature map, resulting in a new set of feature maps that encode the relationship between different features. So we have an input image, and we apply convolutional neural networks to obtain a feature map, and then we apply one-to-one convolution to obtain a key, which is a two-dimensional sets of new features, where 0, it is like encoding of background, 1 is encoding of like some spatial region, and 2 is a encoding of object itself. So this is how query, key, and values are obtained. Next, this is the overall structure of how BoxeR 2D transformer looks like. We have encoder part, decoder part. In encoder part, we have the main layer, which is box attention layer, this one. As input, there is a set of bounding boxes, which are given to the box attention layer. Then there is some layers. The encoder part is ended, and then we have a prediction, which generates object proposals for encoder part. Then from the encoder part, we have some features generated by these layers. So these layers generate some feature maps. Then they are inputted to the input to the decoder instead of like just random object queries. Feature map from encoder are given to the decoder part. Then these object proposals are used as a reference window to generate proposals for decoder part. Let's look on this picture at this picture. So in encoder part, you can see the violet window, which is a reference window, object centering box. Then around this object centering box, we generate different boundary box proposals, which are given to the input to the decoder part. Then we generate object proposal, and this object proposal, meaning this part, object proposal is used as reference window in the decoder part. So I'm not sure if you can see there is a violet window, which is the same as object proposal. And it's used as a reference window for the decoder. And then around this reference window, object proposals are generated. And then the final prediction is made. Is it clear? Sure.
Object proposal is it's generated by BoxeR.
Yes, so this one, object proposals in encoder part. Yeah, they are used as reference window for decoder part. There are lots of like n boundary boxes, but we select like only 10 or 8 boundary boxes, which are used as reference window based on classification score. Yeah, and that is the main structure of the paper and the BoxeR layer. And as it was mentioned 2 weeks ago, the main motivation of this paper is that it outperforms other methods in detecting small objects. And compared to deformable DTR, it outperformed it for 2 APS points than deformable DTR.
We are recording this and then view this video again. And if you still have some questions, please ask me.
Yeah, that's it. And so for next meeting, I will present the paper that you shared with us, OA mixer, object-aware mixer for vision transformer, this paper. Yeah, that's it. Thank you.
But I saw that Luti, you are also saying the OA mixer.
Yes, but we discussed with him.
Still stop the activities one time. Then is there anyone else who presents today?
So I stop recording.